Hi, everybody. There are tons of proofs of the Pythagorean theorem because it's probably the most famous theorem in the history of math. But I just wanted to take a minute to show you a proof of the Pythagorean theorem based off of things that we were working on just in the last unit, similar triangles. So I'm going to label the sides of the triangle A, B, and C because we're trying to prove the Pythagorean theorem, which says that a squared plus b squared equals c squared. C is for this whole side of the triangle though, and I think we're going to need to use little pieces of it. So I'm going to call this segment X, which would make this one C minus X because it's what's left over from C. And then just so that we can have something labeled on all the sides of the triangle, I'll call this segment right here Y, but I don't think we're really going to end up using that one very much. All right, let's start drawing some of the separate triangles. So I'm going to put an arc on this angle here so that it helps me figure out which triangles are similar. So I'm going to redraw this little triangle, but I'm going to orient it this way, right angle and that arc. So the hypotenuse of the triangle is B. Then the leg of the triangle that's between the right angle and the angle with the arc on it is X, and the other side's Y. And I'm going to compare that to the whole big triangle, which was A, B, and C. So this is what I'm going to set up first, and I'm going to set up a proportion and cross multiply. So I'm going to skip the side with the Y, and I'm going to go with B corresponds with C, and X corresponds with B. When I cross multiply, I'm going to get CX equals B squared. All right, hold that thought. I'm going to save that for later, and I want to do two other triangles. So now how about, I'll switch colors again. I'm going to put an arc on this angle, and how about I copy that triangle? So I'm going to flip it around. So that the right angle's here, and that arc is on top. So I'm kind of reflecting my triangle. So the hypotenuse is A, and then the leg that's between the right angle and the angle with the double arc is C minus X, and then the other side of the triangle was Y. And I'm going to compare it again to the whole big triangle, A, B, and C. And I'm going to make another proportion and cross multiply. So I'm going to skip the side with the Y again, and I'm going to say C minus X goes with A, and A corresponds with C. And then I'm going to cross multiply. A squared equals, and then for this one I have to distribute, C times C minus X. So A squared equals C squared minus CX. All right, I'm going to put a box around it, and now I'm going to hold that thought. So I'm going to rearrange my green one actually. Instead of CX equals B squared, I'm going to write it the other way around. I'm going to write it B squared equals CX. So I'm going to scroll back up to see what I was trying to prove. I'm trying to prove that A squared plus B squared equals C squared. So let's see what we have so far. If I do A squared plus B squared, in the purple box, it says that A squared is C squared minus CX, and B squared is CX. So what happens when I add those together? I see some terms that cross out. Minus CX and plus CX cancel each other out. And what we are left with is A squared plus B squared equals C squared, otherwise known as the Pythagorean theorem. So that's just one proof. Feel free to Google and look for all sorts of proofs. There's algebraic ones, there's visual ones, geometric ones. There's even a president of the United States that came up with a proof. So let me know if you find any good ones. Bye.